Simplifying that square root of negative 50. We're now in the imaginary world, everybody. So we are going to keep going whenever I see square root inside with a negative inside of a square root. So simplify that just like you would the square root of 50 and know that means an I can come outside as well. Now if I want to take the I of the 41st power, remember that process, think about it's going to cycle back through powers of like 1 through 4. So if I'm thinking about 41, I can think about 4s going into 41 4 times with 1 left over. So that's going to be equivalent to I to the 1st power. And as a reminder, I know I to the 4th power was equal to what value? 1, on which I forgot to even mention. What was I just equivalent to? The square root of negative 1. So, keeping that in mind, if you ever see I to any exponent besides 1, know that you're going to keep moving forward with that and simplifying. Like in question 3, if I have 3 minus I all squared, remember, take a second, write that out side by side just like this. So multiply it through, and after you multiply it by through, you should have gotten 9. You would have had a minus 3i and another minus 3i. Just combine those together to get minus 6i plus I squared. Ooh, my I has an exponent of 2 here. What do I know I squared is equivalent to? What was that? -1. Great job. This is -1. So to keep moving forward with that, I know this will become 8 minus 6i. Now let's check it with number 4. So I have division with number 4, and most importantly, I have an I in the denominator. Why don't I like an I in the denominator? What kind of math rule is that breaking? Having a what symbol in your denominator? Negative. A radical, that's square root. So to get rid of that, I'm going to multiply by 2 minus I. 2 minus I represents 2 plus I's what? Starts with a C. You better remember that word. Starting with the C? Conjugate. You're right, conjugate. So with your conjugate, remember these terms stay the same. You just flip that middle symbol. So I'm going to keep it positive 2, flip your plus to a minus, and I'm going to multiply my numerator and denominator both by that value. So that way I'm keeping that same equivalent value because this becomes 1. So multiplying through, here's where we're at, and now let's keep simplifying further. And let's just talk about your numerator. So what are you noticing you could keep simplifying through with your numerator? What are some ideas you see just in the numerator to keep simplifying? What are some values you see to keep simplifying with? What do you see, Laura? I can combine like terms. What are some like terms you see?
The minus 3i and minus 8i.
Good job. That'll give me minus 11i. What else do you guys see? What do you see, Alex?
You combine the 2i and the negative 2i can get 0.
Ooh, in the denominator?
Yeah.
Yeah, that's good. So these I know are going to cancel out my denominator. And that's the whole point behind the conjugate, right? I want those imaginary terms to cancel out with my denominator because I can't have an I in the denominator. So that's good. What else do you guys see?
4i squared.
Yeah, what about 4i squared? What is that equivalent to? It is -4. So this will just become 2 in my numerator. What about my denominator? What would be 1? Okay, so this I squared is -1, so you're saying now it's positive because of the minus. Good, so this becomes +1, but I still have to combine it with 4, which means my whole denominator is going to be equal to 5. Yeah, so that first term was a 4 with 2 times 2. So check to see with what you got with your notes. Kind of see where you're at. we're going to keep working with mostly question 1 today. Because what we're doing today is we are going to start solving, everybody, and we are going to start off with a bang in the sense of we're going to start with the one thing that you can use to solve any quadratic equation, and that is our good old friend, the quadratic formula. Who has heard of that quadratic formula before? I love it. Good job. So our quadratic formula we can use to solve any quadratic equation in standard form. So how can I recognize that this is in standard form? What do you see? We've talked about standard form before, and kind of what are some things you're noticing? What should it look like? What's one thing you notice, Akash?
It's equal to 0.
Amazing. Equal to 0. So when you were doing things in like the graphing world, you might have had it equal to y. Now we're in the solving world, which means we want it equal to 0. So using our quadratic formula, we'll have negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So that's going to help us go and be able to solve our quadratic in any situation. So yes, you'll be given your quadratic formula on the test. You don't need to memorize it, but we're going to do it so often that I bet you might end up memorizing it along the way, and it'll be really helpful if you're able to. Yes, we can sing the song if you want. Is that going to help us to memorize it? What is it to the tune of Pop Goes the Weasel?
Yes.
Yeah. So I want you guys to take a second, jot down example 1, and see what you're noticing here. All right, so what are you guys noticing about this quadratic equation? There's some things we should kind of notice from the beginning. What do you see, Yoga? Oh, there's a coefficient for the next grade. What's that? What is that coefficient? 9, okay. What did Akash remind us about last slide? With like, what was our number 1 thing to look for first? If it's equal to? Yeah, so maybe you didn't recognize it because we're already set up right there, right? We're equal to 0, so that's like check number 1. Now I want to go into Yelda's comment about the coefficients. So if I know that I'm equal to 0, I can start solving this using the quadratic formula. But let's take a second and jot down what are our a, b, and c values. So what is a equivalent to here? 9. What is b? And what is c? Great job. So let's plug everything into our formula. So I'm going to have negative b, which is negative 6, plus or minus the square root. And inside I'm going to have b squared. What do I know b squared will end up becoming? Minus 4 times a, which is 9, times c, which is negative 4. And I'm going to divide that all by 2a, which is 9. So why don't you guys take a minute and simplify what you got going on inside your square roots. And if you are using those TI calculators, make sure you understand the difference between subtraction and negative. Negative is next to the decimal or period symbol underneath the 3. Subtraction is all the way on the right with your operations. So what did you guys find our value underneath our square root to become?
6x.
Oh, let's
Oh,
180 all divided by, and then this will become 18. Okay. So is this where we're at? Is this where we want to stay? Did I do my quadratic formula perfectly? I'm all done?
yeah.
Now, what are you guys noticing here that we could keep doing, keep going through? What do you see, gosh?
You can factor the square root.
Ooh, yeah, we can simplify the square root. Do I know 180? Is that a perfect square?
No.
It's not quite a perfect square. So what is the largest perfect square that is a factor?
12.
12 is not a perfect square.
13.
13?
I'm 13.
13 is prime.
36.
36. 36 times what gives us 180?
36 times 5.
Right. So, thinking about it, I can break that down by taking the square root of both those. So this will simplify to 6 root 5. So, kind of back up here, we know we'll have x equaling negative 6 plus or minus 6 root 5, all divided by 18. And now, have we simplified all the way? What do you kind of see that we can still simplify?
Plus or minus.
Oh, okay, yes, we're going to get to that in a minute. Morgan was noticing we do have the plus or minus, so we are going to have two solutions here, but kind of think about all of your numbers except for the radical. You're never dividing inside your radical. Think about that's like a cannot enter zone, similar to like an absolute value. Notice all of these three numbers. What could you divide all of them by? What could we divide them all by? 6. So this is going to simplify to negative 1 plus or minus. You could write a 1 here or just square root 5 all over 3. And Morgan was right with that plus or minus. We are going to have two solutions. So if you wanted to just say your final answer is this, that's great. That's probably where I'll stay because I like writing as little as possible. Or if you wanted to really show where your two solutions are coming from, your two solutions are negative 1 plus the square root of 5, all divided by 3, and negative 1 minus the square root of 5, and all divided by 3. And guys, we're not going to do that and get these ugly decimals. We're going to keep it just like this here. So notice that if I did have a nice perfect square for a square root, I would continue and do those operations, right? Like if this was supposed to just be a 1 here, I would do negative 1 plus 1 and divide it all by 3 to get one solution. And I would also do negative 1 minus 1 all divided by 3 to get that other solution. So, up to you for however you want to show your solution types. What other questions do you guys have from here? Okay, let's go to our next example. Take a second, jot this down, and then see what you're noticing here first. What do you guys notice about example 2?
It doesn't.
We do not equal 0, so that needs to be step 1. So how can we make this equal to 0? Great job, add 1 to both sides. So I'm going to end up with 9x squared plus 6x plus 1 equals 0. So make sure to check you're still in that standard form with your exponents in descending order. So let's jot out what's our a, our b, and our c to help us use that quadratic formula to solve. What do we know? What is a? I heard 9. What is b? 6. And what is c? Great job. So let's go ahead and plug everything into our formula. So we know we'll have negative b, which will end up being negative 6 plus or minus the square root of, we're going to have b squared, which we know is 36, minus 4 times a, which is 9, times c, which is 1. We will divide that all by 2 times 9. Alright, so why don't you guys take a minute and simplify underneath that square root next. And what is going to happen underneath our square root?
0.
It does equal 0. So, and I'm going to keep the square root of 0, which I know is just going to end up being 0. So this is really where you're at right here. You have negative 6 plus or minus 0, all divided by 18. And really what's going to happen if I have plus 0 and minus 0? It's nothing. So my only solution is really going to come from just negative 6 over 18, which I know is going to simplify to, good job.
Oh, no.
So how is this problem different?
You have to make it equal to 0.
Yeah, this ended up, at the beginning? Great. So everyone was noticing we had an extra step at the beginning. We had to make it equal to 0. How else was this one different from the time before?
I only had one solution.
Yes, we only had one solution because why? Well, how did I only have one solution? Great job. The square root equals 0. So that's a thought we're going to come back to in a little bit. Any other questions before we try our next example? All right. Why don't you guys take a second, jot this down, think about what your first step would be. All right, guys, what are you noticing here with this example? What are you guys thinking about? What do you see? What have we been talking about with kind of like, before we start using the quadratic formula, what is one thing we need to make sure about?
Make everything equal to 0.
Make it equal to 0. So are we equal to 0 here?
No.
No. What are some thoughts? How can we make it equal to 0?
Minus 5 plus 3.
Good job. So Arch has the same kind of intuition as me, where I always move it to make my x squared term positive. You know, sometimes that just means like an extra step, but for me, I always like that leading term to be positive. But if you like to do a little less instead, and you move your 3x squared to the other side, that's okay. You're still going to get the same solution in the end. But maybe your a, b, and c values might look a little different. So what's our a here? 3. What's b? Yes, and what is c?
3.
Great job. So I know I'm going to start my quadratic formula. So I'll have negative b. What's negative b become? Positive 1. Plus or minus, and I have the square root. And what is b squared? 1. Always know your b squared term is going to end up being positive. Negative times negative is still getting us a positive. So I have minus 4 times a, which is 3, times c, which is 3, all divided by 2a. So why don't you guys take a second and simplify underneath your square root. See what you got. Alright, so what happened? What did underneath that radical that square root simplify to?
Negative 35.
Good job. So I have negative 35. So are we done with our problem here?
No.
What do you guys think? What do you maybe seeing?
I.
Awesome. I have a negative square root. So that means I still can simplify. Because that means I have that I want to take care of. Remember? Now I can tackle that negative inside my radical. So if I have negative, the square root of negative 35, can I break down 35 anymore? Does that have any perfect squares? No, right? It's just 5 times 7, and those are both prime. But I do know I can simplify it because it's negative. So how can I simplify the square root of negative 35? What would that be equivalent to? Just I. Yeah, it would just be I square root 35. Because think about now I have that positive inside my square root. Right? I want that. And I have my I outside. So here we're going to have x equals 1 plus or minus I root 35 all divided by 6. And could I simplify that even further? What do we think? Could I simplify that any further? No, so that's where I'm at. I'm done actually. And you can leave it just like this. Or you could write out 2. What's up, Evan?
What's I?
What is I? Who can remind Evan? What's I?
Square root of negative 1.
Good job. That is our square root of negative 1. So if I have a negative, Evan, were you here on Friday? Neither was I, but I posted a video for you to like catch up. And kind of go through. So maybe rewatch that. And that's all about our imaginary value. So if you have a negative inside your radical, that is meeting now. You're going to have that imaginary value with I. So let's talk about these 3 different problems and how they were different. So kind of going back through, this was example 1. And we ended up having 2 real solutions with our answer. This was example 2. And remember we had 9x squared plus 6x plus 1 equaling 0 first. Who remembers with example 2, what was our answer? What was our answer type? Yeah, it was 1 answer, right? So we only had 1, and that was a real value. What about our problem we just did? What were those solution types looking like?
Had 2 imaginary solutions.
They had imaginary. Great. So this was 2 imaginary, or you could say complex solutions. Meaning these were not real, right? I know they were not real because they had that I with it. Now we talked a little bit with our second example about why this happened with only getting 1. Who can remind us, why did we only have 1 real solution in our second example?
Square root was 0.
Good job. We ended up with our square root being 0. That's why we only had 1 real. Why did we end up with 2 imaginary? What happened with our square root?
We had a negative in it.
Good job. We had the square root, what was it, like negative 35, right? So we had a negative underneath our square root. And then, what about with like that first one? We didn't really run into any issues. We had kind of, what were some things you noticed to help us get our solution there? I ended up having 2 real solutions. Why do you think that would occur? We did 2 because we were able to do that plus and minus, right? And there was like another value there. And did I have any issues with that other value? No, it was still just positive underneath our square root. So that was the square root of 180. So then we had that positive like a positive number under a square root. So all of these tell us about the solution types when we are looking underneath the square root. So underneath our square root is equivalent to b squared minus 4ac, which is this idea called the discriminant. So our discriminant is what is underneath our square root, and your discriminant tells you about the nature and like what your solution types will be. So just like if my discriminant ends up being a positive number, that's just like in example number 1, you're going to end up with 2 real solutions. If my discriminant ended up equaling 0, that was just like example number 2. You're going to only end up with 1, right? Because you're going to plus or minus nothing. So that just kind of only gives away 1 solution. Now, if my discriminant ends up being less than 0, aka a negative number, that was like the situation we had in example number 3. I'm going to end up having 0 real solution because what are these solution types? Imaginary or complex. So you might say 0 real solution or 2 complex or imaginary. What questions do you guys have here? So big thing to note is that the discriminant tells us about what those solution types are going to be. And we can use that quadratic formula to solve anything. So I have 2 more examples for you guys to try. We have about like 10 minutes left in class. So I'm going to put one on the board, give you like a couple minutes to work on it, and then I'll put the solution down for you to check. And then we'll do that again. So we'll kind of get through those 2 for the last part of class. What other questions do you guys have here before we do that? All right, so why don't you guys try this next one, and then I'll show the solutions in just a minute.